transistors. So the chapter that is known is actually bipolar transistor. Bipolar transistor. So actually in 1951, it's near about 1951, the scientist that is actually William, you can say Schottky, that actually invented the first junction transistor. First junction transistor was invented by this scientist in 1951. That is a semiconductor device. What is transistor? If someone asks you what do you mean by transistor, then a transistor that is nothing but, you can say, a semiconductor device, a semiconductor device that can amplify, that can amplify or enlarge, amplify or enlarge electronic signals, electronic signals such as radio and televisions, such as, you can say, radio and television signals. So you can say the transistor is a amplification device. Generally it is called current amplification device, and the transistor that has led to many other semiconductor inventions like integrated circuit. We are now using IC, that is IC chip, that is called integrated circuit, where we use millions and millions of transistors in today's world, like your phone's motherboards or your computer motherboards. That is nothing but a integrated circuit. That means a small device that contains thousands of transistors. So because of this integrated circuit, the modern computer and other electronics miracles are possible, right? So this particular topic introduced the bipolar transistor, the kind that use both free electrons and holes, right? There means, if we modify the transistor in your syllabus, there is only, bipolar transistor, bipoles. That means here bipolar means two polarity, two polarity. That means in that case they uses both free electrons, they uses both free electrons and holes as a communication medium. And that's why that means two polarities. There are two polarities, and from that this bipolar transistor name came. That means bipolar, right? Bipolar means, you can say, that has two poles. That means the current carrier are either electron or it may be holes, right? But nowadays we are not stick to the bipolar. Actually that is not included serious syllabus, but still you should know that in our syllabus, in your class 12 syllabus or NEET syllabus or JEE mains advanced syllabus, only the bipolar part is included. But when, if you go for the higher studies, you will see there are next transistor that already been developed, that is called FET. FET means that is called field effect transistor. There is a modification of that. That means in that case both electrons and holes are used. In case of FET, only one charge carrier are there. That is a field effect transistor. And then it is again modified. Modified means it is now MOSFET. This is also different type of transistor. MOS means This is a metal oxide. That means this particular metal oxide semiconductor. Metal oxide semiconductor field effect transistor. And this MOSFET has two parts. That means one is NMOS and one is PMOS. And by using this NMOS and PMOS, nowadays we are building CMOS. This is called CMOS, or you can say complementary MOS. Complementary MOSFET. This is complementary. And now in today's world, we are all designing the your computer or chips, whatever be the thing, by using CMOS. But you know the basic transistor configurations are same for both cases. The only the techniques are different. If you studies higher, that means the transistor, what are the problem in bipolar transistor, that would be rectified in FATE. What is the problem in FATE, that would be rectified in MOSFET. And now we reaching at the CMOS configuration. So the first thing is that a transistor, that means a transistor খুব ভালো করে বুঝবে ব্যাপারটা, এটা পুরোটাই basic understanding should be clear. So actually you can say a transistor transistor you can say has three doped region, has three, you can say, doped region. Generally, either it can be NPN or either it can be PNP. NPN means this is a N type, this is a P type, and then another N type, or it should be P type, N type, and P type. That means either you have to place back to back diodes, because what do you mean by diodes? This is the diodes where you know this side is P side, this is the N side. That means if you build the transistor like that back to back diode, then that should be PNP like that. So it should be like that, but of course that is not built just by putting two diode back to back. But either transistor has two pipe, one is the NPN type or another is the PNP type. So first we will see the unbiased transistor. That means what will happen basically. Unbiased transistor. We already told you that what does it mean of unbiased? That means you are not applying any battery, right? So what is this? If I am discussing about that means uh, NPN transistor, you can describe it by using only one transistor. So I am saying that we are using basically NPN. So what is NPN, right? So already we know that if this is the corresponding N side, in middle of this there is a P side, and this is the N side. Generally P side, the width of the P side, that is less compared to the N side. So what we know in the previous class, that in case of semiconductor device, when you represent the PN junctions, that means inside, that should be represented by the bound charges. Bound charges means for n charge, the bound charges, that means the charge that will not move, that is due to the minority carrier. And this is nothing but, you can say, this is a representation technique, right? So P side is represented by that, you can say, since it is less width compared to the n, so I am just writing two rows. So this is a positive side, this is a N side, say. Now you know already that there are free electrons. Say I can represent the free electron by different color. So in inside, the free electrons are negative, these are the corresponding free electrons, and these are, you can say, positive, these are the free holes, these are the corresponding, you can say, electrons, right? So this is nothing but, this side, you can say, named as a collector. Why it is named as it? We will see it later. This middle portion is called base, and this portion is called emitter. This is a, by using these three, we are just creating the transistor. So you just remember one thing. What will happen? What will happen? So that is a unbiased transistor. So what will happen, that this electron, that means within this junction, this is the junction, one junction is this one, another junction is this one. So this electron will cross the junctions, and that will form the depletion region, right? And for that also the electron will cross the region, and that will form the depletion region. So in the next sections, if we draw it, that means after crossing the electrons throughout the junctions, the pictorial diagram should be like that, like a diode. This is a same representation. This is nothing but a same representations, only the free electrons around the junction that will cross the junctions, and that will move in the opposite side, right? So it will be better if I am taking another line, then it should be more relevant. So it will be better if we take another line, that will be better. Mm, so this is a positive, this will be positive, and this will be, representation is like that. Now what will happen? The electron around the junction, that means this electron will cross the junction, and as well as this electron will also cross the junctions, because PN junctions. That means when you are forming the PN junction, automatically the electrons from this end side that will crosses the junctions, and as well as from the electrons from this side will cross the junctions. So around the junctions, you can say, that are depleted of the mobile charge carrier. That means this is the junctions, and that particular junctions is nothing but the depletion region, right? And this is called the deep, you can say, depletion region, and that is also, you can say, this is a depletion region. And for that, you can say, because this is the corresponding junctions, this electron will cross this, so this section is the depletion region, and as well as this section is the depletion region. And and the rest of the sections, there are free electrons, so I am just denoting with different colors. So the free electrons are remaining there, right? Only within the junctions there is no free electrons, and there is a positive charge that is remaining. So only within the junctions there is no free electrons, because within the junctions there is a depletion region. Now what will happen, when you from the depletion region, that means no current will be flowing through the circuit unless and until you are given some voltage across that. So that means no current will be flowing, but my target is to, you have to flow the current, right, from these junctions, emitter junctions, to collector junctions. Collector means it will collect the electron which is emitted by the emitter junction. That means emitter junction with emitted the electrons, and the electrons are collected by the collector, and that's why the current is flowing through the circuit. But since the depletion region is formed, and from the PN junction diode that until and unless you are not applying any voltage, the current will not flowing through the circuit. And that's why we need the biased configuration. We need the biased transistor. Biased transistor is meaning is nothing but, you can say, I am just applying the voltage, right? So now you have to apply your common sense, right? What I am saying, the emitter junctions that will emit the electron, and the collector means it will collect the electron which is emitted by the emitter junctions, and depending on that you have to apply the voltage. Because in case of PN junction, that is very simple, because this is a P side, this is the N side, and you are applying, this is a positive side, this is a negative side. you are applying, this is a positive, that means this positive will attract the electron, so the current will be flowing through these directions. That is a simple thing. But in that case, there are lots of junctions are there, right? So in that particular case, what will happen in that particular case, since this is the corresponding transistors, right? So actually the width of the base is very small, right? So this is the inside, this is the p side, this is the n side, and I am just taking about the electrons, right? So there are lots of electrons in the emitter junctions. So what you have to do, you have to apply the battery such that this electron will be attracted, and that would be collected by the collector. This is the the collector junctions. This junction is called base junctions, and this junctions is nothing but a emitter junction. So I can apply the voltage. That means if this is a resistance, so what you understood, that means this electron should be attracted. So that means you have to apply the positive supply, positive side to that junctions, right? You have to apply the positive side. That means if you are applying this positive voltage, that means this electron will be attracted by the base junctions, and you have to collect it. That means the electron should be collected. Since electron should be collected, that means this particular junctions where also you have to apply a voltage, that is the positive side, because electrons should be in the base region, and from the base region you have to attract the electron such that it moves to the collector, then only the current will be flowing through the circuit. That means in collector junction you have to also apply the positive voltage, because positive voltage will attract the electrons, right? So the circuit diagram should be like that if you want to get the current. And this is nothing but I am just naming, this is a base. Since this named as a base, so I am writing RB, and this is the voltage, say VVB. This is a positive, negative, and this is the N side, this is a P side, this is a N side. I am just giving, this is a resistance, this is RC, and there is a voltage, that is VCC, right? So there are two voltage. One is called base emitter voltage, and one is called, that is called collector emitter, because that voltage which is applying, which is already from there, that means this is a base emitter voltage VBE, and this voltage, this voltage before the resistance, this is a collector emitter voltage, right? This is nothing but the collector and emitter voltage, this is VCE. So in that particular case, I think you understood the case why I am applying the battery in such a way, because I want a current from the emitter to the collector junction. That means whenever the electron that will flow from emitter to collector, then we will get the current. So the thing is that there are first questions that we encounter. The first thing is that the base junctions, the this particular base, that is lightly doped, that is lightly doped and very thin. Why we should maintain that? That means this particular base junctions, it is a lightly doped and very thin. So why it is lightly doped? What do you mean by lightly doped? That means what we actually want. I want that electron should flow from base to collector. So if the base is lightly doped, like that, what will happen? The electron will coming to the base junction. There is two possibility. One is it can goes towards the base, either it can goes towards the collector. So what I want that such that the electron should go to the collector junctions. So some of the electron may go to the base junction also. So that's why if this is a lightly dope, that means the electron can reside more time within the base such that the collector can collect it. That means you can imagine that in your house there is a capability of staying the house has two door, right? Two door. One is the open, and one is the indoor, and the one is the outdoor. And the house has capability to maintain 5 persons, right? So what will happen? 5 person at a time. Now already your house is almost filled. That means 4 persons. And you know there is two outdoor. One is the base junction, that is the one of the outdoor, and one is the collector junction, this is another outdoor. Now what will happen? When the other people is coming through the in junctions, already that almost filled, that means 4 people are already inside the house. When the more people are coming, what will happen? They will give push to the people, and the people will running out quickly. Either it can go to the base out, or either it can go move, it can be out from the collector junctions. So the problem is that I have to give a time to the collector junction such that it can attract the people, such that the people will understand and it can easily go out from the collector junctions. That means the reason for the lightly doped is that lightly dopes actually it means that the the free electrons have a long lifetime, have a long lifetime in the base region. If it has a long lifetime, that means there is a more probability that collector will collect the electron from that. And the very thin base, the very thin base, the reason is that means, you can say, means that the free electrons, have only, you can say, have only a short distance. A short distance, that means যত thin base হবে, that will travel a short distance to go to, you can say, reach the collector. That is the thing. For this two reason, almost all the emitter injected electron pass through the base to the collector. For this two reason, for, you can say, for this two reasons, for this, you can say, two reasons, almost all the, you can say, emitter injected electrons pass pass through the base, pass through the base to the collector. So now what will happen? The collector will carry the current. That means, you know, what is the summary? You can say, in that particular case, say this is a p side, this is a n side, you are applying positive voltage to the p side and you are applying negative voltage to the n side. That means this vb will make this pn junction is in forward bias, right? Because that will forcing the free electron in the emitter to enter the base, right? And the electron flow through the collector through RC, what we are saying, I am applying, you know, the positive side in the n, and as well as you are applying positive side to the n, right? So that means what will happen? The this collector emitter junctions is in nothing but key in reverse bias, right? Because what we know, when we are considering diode, if this is a p side, if this is a n side, when we are applying positive voltage to the p side, that is a forward bias. And when we are applying positive voltage to the p side, uh, you can say that is the reverse bias. Reverse bias means you are applying the battery like that. This is the reverse bias. That means what will happen? negative terminal of the battery is connected to the P junction, and positive terminal of the battery will connected to the N terminal. And you just see in the output, the VCC, the positive terminal of the battery is connected to the N side, right? So that is the interesting phenomenon, right? This is the one of the interesting phenomena. So from that, what we understood, that this VBP, PBB, that will make the circuit in bias. Forward bias. This VBB is in forward bias, right? And and of course the battery, that is VCC, that will make the output circuit to the, you can say, reverse bias. So now you know. So now if you just write this particular configuration into symbolic diagram, the symbolic diagram should be written like that. That means, how can you remember this? There is two things, because there are two transistors. This is a symbolic diagram, right? This is, you can write like that, PNP, and this is the NPN. What, how can I remember that? There is a three junctions. When the current will always flow from P to N side, you just see, if this is a diode, the current will flowing from P to N side. That means I am giving this direction, P to N side, that is a directions, and in that case the direction is opposite side. So when you are giving this directions, this is called NPN transistor. That means for NPN transistors, what will happen? The current direction should be, and this junction, where this is called the emitter junctions, this is the base junction, and this is nothing but the collector junction. And this is transistor is NPN transistor. In that case also, this is a base junctions, this is an emitter junctions, this is an collector junctions, and this is a PNP transistor. Because what I already told you, that there are only two type of transistors, one is PNP and one is NPN, right? So in PNP and NPN, that will be like that. So you just understood, this is the symbolic representation. Now what will happen? You know the circuit, what will happen? The current, that means the electron from the emitter junctions, that will flow to the base. Some of the electron may, that will move to the base junction, and the remaining one, the most of this, they are moves in the collector junction. That means the electron is flowing in that direction, that means the current is flowing in the opposite directions. That means actually this is the current directions is IC, there is a current, this is IB, and there is a current that is called IE, right? That because the direction of the current is opposite to the directions of the electrons moving. So in that case, you can say this is NPN. That means the current, this is the IC. In base junctions, this is a current is IB, and in the collector junctions, there is a current is IE. That means what you can understood, that IE can be written as IC plus IB. That is the equation. That is the equations that we already from. And there is a some quantity that is called alpha. This is called, you can say, alpha. Alpha is nothing but there is DC alpha, that means that will not vary. So you can say that is defined, DC alpha, that is defined as the, you can say, DC collector current divided. This is a symbolic, this is a representation, that are the parameters, right? Nothing but that, by the DC emitter current. This is emitter current. That means alpha DC, this is nothing but IC by IE. You can write alpha is the collector current divided by the emitter current. You can write, this is called the transistor's current. And there is also another representations, that is called beta, that is called beta. And beta is nothing but this is called DC beta. DC beta, that means fixed, that will not change, and this is symbolized as beta sign, and this is nothing but, you can say, the ratio of the DC collector, DC collector current to the DC, you can say, base current. That means you can say beta DC, that can be represented IC by IB. That means this is the ratio between, and also this is called, you can say, current gain. This is called current gain, because you can say, because small base current that will produces much larger current, corrector current. তার মানে এখান দিয়ে কিন্তু আমরা এটা দেখাতে পারি, because this is the current amplification device which I already told you. So what does it mean, current amplifications device? That means generally the value of the beta, that is 100 to 300. Generally the value of the beta within the range 100 to 300. That means if I am giving a simple base current, that will be multiplied 100 times or 200 times, and that will give you the collector current, right? That means that is a simple thing. That means if you can say, it is given that a transistor, a transistor has a, you can say, collector current, collector current of, you can say, 10 milliampere, and a base current, and a base current of 40 microammeter. You just remain, this is the range, this is a micro, and the collector current in the range of milli. That is generally that will happening. So if you have to find what is the current gain, what is the current gain of the transistor, what is the current gain of the transistor? That is simply, you know, beta DC, that is, you can say, the ratio of IC, and this is the base current. Collector current is 10 milliampere, that is 40 microammeter. So you know milliammeter means 10 into 10 to the power minus 3 ampere, and you can say micro means 10 to the power minus 6. So if you divide it, it will near about, it will give you 250. It will give you 250. This is the simplest. I just giving you the hints that that is nothing but, you can say, the, this is nothing but, you can say, the output current, like that, right? So this is the ratio. That means beta is one of the important parameter. Beta is one of the important parameter, right? And that is one of the most important parameter. Why? Because you know that will give you the ratio. Okay. So you can say that that is nothing but the relation between alpha, and the relations between, I have to find the relations between alpha and beta, because that is also one of the questions that will ask you that what should be the ratio of that. So for that purpose, what we can think of that, right? What we can think of that. So you already know the equations, right? You already know the equation. What is the equation? That the current, that means the collector current and the base current, that will give you the emitter current, right? This is the equation, right? So, and already uh, we know, I'm just giving an approximation proof, right? This is an approximation proof. So I have to find the relations between them. So relations between alpha and beta. So from that, what we can get, that this beta DC is nothing but IC by IB, and alpha DC, that we will get the value is IC by IE, IC by IE. That is nothing but IC by IE. That means you can say IC is equals to beta DC into IB. I can write like that. And as well as in that case, you can say that uh, that IE, that means I can write IC is equals to alpha DC into IE, right? So if I am replacing the value, if I am replacing the value of IE, that means because that is the relations between IC and IB, so I can write IE, that is nothing but 1 by alpha DC into IC, right? So I can put this value. So I can put this value. This is IC, this is IB, and this is IE. IE is 1 by alpha DC by IC. So IC, if I am taking as a common 1 by alpha DC, and that is equals to IB, right? Minus IB. And so this is the alpha DC, this is the alpha DC minus 1, IC equals to minus IB. So I can write like that. So IC, if I consider the negative sign, this is the alpha DC by 1 minus alpha DC into IB. So I can find this relations, and already I have a relations like that. From if you compare this, so I can find the relations between these two is like that. That means beta equals to alpha by 1 minus alpha, right? So beta is equals to alpha 1 minus alpha. That is the corresponding relations, right? Or if you add like that, if we add plus 1 both side, that means that will give you 1 by 1 minus alpha DC, that is 1 plus beta. That is also just I am adding this. It may be helpful when you try to solve the problem, right? So uh, in that particular case, if you see the circuit, if you see the that particular circuit, this particular circuit, what you understood, if you, there is some resistance, right? This is the input resistance. I'm not talking about RB. There should be some resistance that can be found by the voltage divided by the current, right? And as well as there should be some output resistance also, where the voltage is VCE, and if I am dividing with the current, that is IC. So I can say there should be some input voltage, that is nothing but change in the uh, you can say base emitter voltage by IB, voltage by current, when I can say VC is making a constant, and there should be some output resistance, which is also output voltage is change in output voltage, that is a, I am just writing delta sign. That means this is the AC voltage. If you are given AC voltage, so that will fluctuate. So I am taking like that. This is a VCE by IC, and where the input voltage IB that makes constant. This is the two parameter. One is the input voltage and one is the output voltage. Nothing but that. So in that particular case, we will get the relations between alpha and beta, right? So the thing is that the thing will be like that. Mm, it may be the simple questions that may ask. So that's why I am just written this particular factor. That means you just remember one thing: when I am written delta, that means this is the AC current, right? And when I am written the constant quantity, like you can say both are the same thing, don't confuse. That means if I am written alpha AC, what will happen? If I am written alpha AC, alpha AC is nothing but I am just represent the symbol like that, right? If I am writing beta AC, AC means, that means fluctuating, that means this is del IC by del IB, right? So you just don't confused with that representation. This is means alternating current, and this is nothing but alternating current, and these are the DC current, nothing but that. So if the questions That is the simplest questions it may ask. That if the question is formulated like that, say a, you know, change of 250 millivolt, 250 millivolt in base emitter, base emitter voltage, that will causes a change of 1 milliammeter in the base current. Determine dynamic input resistance, dynamic input resistance. So when you have to find here, this is a change in, base emitter voltage that is given, that is 250, millivolt, and there is a change in the base current, that is nothing but 1 milliampere. So if you want to find the input resistance, that is nothing but voltage, input voltage by input current, that means that is nothing but 250 millivolt by 1 milliampere, that means 250 ohm. That is a simple. The question is not complicated, but the thing is you have to know the basic thing. If you know the basic thing, you can solve the problem. I'm sure about that, you can solve the problem. So in that particular case also, it may be the question is given like that. It may be the question is like that: increase, say it is given like that, increase in collector, increase in collector emitter voltage from 5 volt to 10 volt, that causes increase in collector current, increase in, you can say, collector current from 5 milliampere to 5.8 milliampere. You have to determine the dynamic output resistance, dynamic output resistance. So in that case, the increase in collector emitter voltage, that means collector emitter voltage change, right? You have to find. Finally, it is a 10 volt, and from initially this is a 5 volt. That means the change is 5 volt, right? And increase in collector current, that means the change in collector current, that is nothing but 5.8 minus 5.0 milliampere, that means 0.8 milliampere. And you have to find the dynamic output resistance. Output means output voltage by output current. So you can say this is change of output voltage by change of, you can say, the output current, and this is 5 by this is a zero point 0.8 milliampere, mean 10 to the power minus 3, and that will give you 6.25 kilo ohm. That is the type of questions that may ask you, right? So this is the, you can say, we will see lots of questions, we will see the lots of questions. So the thing is that we can solve it like that. Simple questions they may give like that. If they will see that the value of I, that is given 5 milliampere, and value of IC, that will give you 4.95 milliampere, you have to calculate, you have to calculate beta DC. বলো দেখি, যদি এরকম একটা সিম্পল কোশ্চেন থাকে, আই এর ভ্যালু দেওয়া, আইসির ভ্যালু দেওয়া, বিটা ডিসি বার করতে বলেছে, স্নেহা বলো তো কি হবে? And as well as to my, you have to find the alpha DC. তো বলো দেখি, anybody? How can we find the beta DC and as well as the alpha DC? What did you think? That means in that particular factor, what do you have to find? Because what you know that beta DC, that is nothing but IC by IB. But in that particular case, you don't know about the IB, right? But you know the relations. What we know that IE, that is equals to IB plus IC. You know that. That means you can find easily IB, because the value of IE minus IC, that will give you the value of IB. So IE is 5 milliampere, IC is 4.95, you can say milliampere. If you divide, if you subtract this particular thing, what will happen? You will get the value. So that means in that case, the value of IB that you get, that is nothing but, you can say 0.05, right? 0.05 microampere. That means that is 50 milliampere. So that means 50 microampere. So if you want to find the current gain, that means beta, that is IC by IB. IC is 4.95, IB, that is 0.05. That means that will give you 99. That is a beta DC. And you know the relations between alpha and beta. The alpha DC is equals to beta DC 1 plus beta DC. That is also another relation, because beta and alpha that are related to like that, we will get the same thing but just interchanging the thing. That is 99, and you can say 1 plus 99, and that will give you 0.99, right? So this is the current gain factor, right? This is the current gain, and another one is the current amplification factor, right? So this is the, you can say, current gain factor, and this is nothing but current amplification factor. Amplification factor. So these are the two things. That means the problems for that particular what we already discussed, the question should be like that, because you will see in different NEET also, they will they want to ask you the value of alpha, if the value of beta is given, or something else. Now the thing is that we have to uh, slightly go deeper, right? We have to slightly go deeper. So the thing is like that. So the thing is like that, uh, what I want to say, that means if you see the picture, if you see the corresponding picture, what will happen? This is nothing but, you just see, this is the emitter junctions, and you just see base region is also connected to the emitter, as well as collector region is also connected to the emitter. That means emitter is common. Emitter is common, and this type of configurations is known as common emitter configurations. That type of configurations, that is known as common emitter configurations. So I am just writing it by using this symbolic diagram. That means NPN is nothing but, the symbol is like that. So you just remember one thing, what will happen if we write the diagram like that, because the diagram is like that. This is a N, this is a P, this is a N. What we apply, there is a resistance, this is a called base resistance, RB, and I am applying this battery in a forward bias. This is nothing but VBB. So emitter is common, that means emitter is in ground. That means from collector, what we know, there is some resistance, this is a RC, and I am applying a voltage VCC. This is a voltage VCC. that makes the collector emitter junctions is in reverse bias. This is a positive side, this is a negative side. And you understood the thing. That means the base current will be flowing like that, IB. The collector current will be flowing like that, this is IC. And as well as this is the emitter current that will be flowing like that. And also know, in that region there is a voltage that is called base emitter. So I am written like that, base emitter. And as well as, in that region there is a voltage, this is called, you can say, collector emitter, VCE. This is a collector emitter voltage. So now if we want to find IB, right? If we want to find IB means in current. That means, if you just go through the diagram, then what you understood, that here the voltage is VB, here the voltage is VBE. That means the remaining, the voltage that is applied, VBB minus VBE, divided by the total resistance. Resistance is RB, and that will give you the current IB, right? That will give you the current IB. And as well as, if we just go through the output circuit, what you will understood, that means this is the voltage VCC, right? And the current will be flowing through this. This is the IC current that will be flowing through this. So you can write that, what we know, that this VCE plus this ICRC, that totally gives you the voltage VCC. That means actually VCC, that is nothing but VCE plus IC into RC. That is simple thing. That is the output voltage. So you can say that VCE is nothing but VCC minus ICRC. If we rearranging the equations, this we can get that equations from the output circuit. So if you have to find that how much power that will dissipated by the transistor, that means called the power dissipation of the transistor, that is nothing but, you can say, that is VC, that is the voltage across the transistor, output voltage, and output current, this is IC. If we multiply voltage into current, that will give you the power dissipation. মানে power dissipation যত বড় হবে কি হতে পারে, তত উড়ে যেতে পারে, রাইট? মানে একটা সময় if you cross this, then it may be possible that the transistor will burn out যদি তোমার power dissipation, if that should be more than that. So now you can say that, say a circuit is given like that. Mm, say a circuit is given. So I think you should clear about that. What should be the value of the base current? How can we find what is the collector current, collector voltage? Now if the circuit diagram is given like that, that means you just say this is the voltage, this is a 10 volt, right? There is a resistance, say 1 mega ohm. This is the corresponding transistors, and the voltage across the transistor, that is VCE, output voltage. And this is, you can say, 2 kilo ohm, and that is nothing but 10 volt, and that is, you can say, this is the corresponding circuit is given. Now the simple questions, this circuit is given, data is given, and now what you have to find, this is a beta DC, that is 300, and you have to calculate IB, you have to calculate IC, you have to calculate VCE, and you have to calculate the power dissipation across the transistor. That means beta DC is 300, you have to calculate, you can say, IB, you have to calculate IC, you have to calculate BCE, you have to calculate PD. That means power distribution across the transistor. Power distribution across the transistor. So how can we find? Because this is the IB, what we know from the circuits, that what we know, that is nothing but the IB. Here the current is IC, here the current is IE, and we already know how can we find the IB. IB is nothing but this is a VBE minus there is a voltage that is VBE, right? So VB, this is VBE. You can say this is RB. Now you just remember, we will explain it later. What I am saying that when you are connecting, this is a N, this is a P, this is a N. So P side is connected as a positive terminal. So that means this is in forward bias. So what we know, the forward voltage, that means this VBE is nothing but the forward bias voltage. And you know the forward bias voltage is nothing but 0.7 volt. So you can say this VBE is 10 volt. VBE is, you know, this is a 0.7 volt, and the resistance that is given, that is 1 mega ohm, right? So you can say this is 1 mega ohm, and if you calculate it, you will get this is 4.3 microampere. So this is nothing but IB. Now if you want to find the collector current, what we know, value of beta is given, right? Beta DC, that is value is given. So what we know, we already know the relations. That means beta DC, this is nothing but IC by IB, right? So you can directly find IC is equals to beta DC multiplied by IB. Beta DC is 300 multiplied by IB, that is 9.3 microampere. If you multiply this, that will give you milliampere. You just imagine, this is a milliampere, this is a microampere. That means million micro, that is a 10 to the power minus 6, and this is a 10 to the power minus 3. That means thousands times difference is there, right? So IC, that means the output current gain. We will get the output current gain. So that's why I am mentioning that transistor is a current amplification device. You can use as a switch itself, but one of the major advantage of the transistor, that is it can be used as a multi amplification device when we place the transistor in common emitter configuration. But of course the transistor has also other use. That means the transistor can be used as a switch, right? So this is the IC. And if you want to find the VCE, if you want to find the corresponding VCE, VCE is nothing but, you know, output voltage VCC minus IC into RC. So VCE is 10 volt, IC, that is 2.79 milliampere, and the resistance is RC. RC means 2 kilo ohm, right? 2 kilo ohm, because here the resistance is 2 kilo ohm. You just see this is the 2 kilo ohm, and if we multiply this and divide it with the subtractions with the 10, that will give you the voltage 4.42 volts. And you know the power distribution. Power distribution is VCE into IC. VCE is 4.42 volt, and what is IC? That is 2.79 milliampere, and যদি multiply করো, that will give you 12.3 milliwatt. So this is the type of thing, type of, you can say, problems. This is a, আমরা আস্তে আস্তে আরো কঠিন প্রবলেমের দিকে তোমায় যেতে হবে, but this is one of the, you can say, simplest problem. You can think of that. So now we will see some graphs, right? We will see some graphs. So there are two type of graph. One is called input characteristics, and there is something that is called output characteristics. This is one of the graphs, that means input characteristics. So input characteristics means actually input voltage by input current. the গ্রাফটা হবে আমাদের ইনপুট ভোল্টেজ and input current with respect to when you can say output voltage is constant. Output voltage is constant. So you just see the diagram. What is the input current? What is the input voltage? If you see the diagram, any diagram, the input current, that is IB, input voltage, that is VBE, and the output voltage, that is VCE. That means you have to fix the VCE and then you are increase the input voltage with respect to input current. So you just imagine the thing. That means we are increasing the input voltage, that is VBE, and how the input current IB will behaving when you are fixed the voltage, output voltage. মানে VCE কে fixed করে দিয়েছি and I am increasing the voltage, base emitter voltage, and we will see how the base current will vary. So you just remember, you don't have to remember anything. This is nothing but a PN junction. This is nothing but a PN junction. And this is nothing but a forward bias. That means that is simple as the curve of the forward bias curve. We already know that how the forward bias curve will behave. That means up to 0.7 volt, you will not get any current. And when it crosses the 0.7 volt, you will get the current, because until and unless there is a depletion region, we already know that. That means in that case also, there is some depletion region that is also forming. This is, we already show that there is something depletion region. That means depletion region means across the depletion region there is some barrier potential, and this is near about 0.7 voltage. That means until and unless the input voltage is greater than 0.7 voltage, you will not get any current. That's why you can say, I am just, if we just draw the input characteristics of the circuit, input characteristics, that is simple. That means this is nothing but the input current, this is the input voltage, this is VBE. Up to 0.7 volt I am not getting any current, and up to and after 0.7 volt I am getting the current, like that. This is simple as a forward bias characteristics curve. This is simple as a forward bias. Forward bias diode যেটা পড়েছিলে, that is simple as a forward bias. But you have to understood the thing that is called the output characteristics. That is called output characteristics. The thing is that in that case, so input characteristics, input voltage, that is VBE, input current, this is IB, output voltage, that is VCE, right? This is a VCE. That means VCE is fixed, right? So that should be. And what is the output characteristic? That means same as output voltage versus output current, right? So output voltage versus output current. Output voltage versus output current, where we are constant the input current. Input current is constant. Input current, that is equals to constant. So in that case, what is output voltage? That is VCE. What is output current? That is IC. What is input current? That is IB. That means you have to draw the curve between VCE and IC, and IB should be constant. You just keep focused for some few minutes, because you have to understood the concept, right? Because that is one of the important concept, that how we can draw the output characteristics. Because if you understood the thing, that is very easy. So what the transistor is like that. If I am saying I am redraw the transistor, this is the corresponding transistor, this is the corresponding base junctions. We already know there are lots of electron in the region that is called this is called the emitter region, right? And this is the corresponding base region, and this is the collector region. And what is our aim? Our aim such that we have to place the battery such that the electrons from the emitter junctions that will collected by the collector. So that's why the current will be flowing. And this is a current amplification device. That means my target is to, the collector current should be as maximum as possible, right? So what we did, we take a resistance, we connect a battery in the forward bias. There is a simple CE configurations. This is a, this is a VBB, this is a positive side, this is a RB, and we will get some current IB. And already this junctions is connected in a reverse bias. That means you have to attract the electrons. Since you have to attract the electrons which is emitted by the emitter, so you have to place the battery in a positive terminal should be connected in that, and this is a NPN transistor, right? Now you understood the first thing. The curve is whatever be the curve, you just understood. The curve is what we want to draw. This is between the output voltage and output current, where the input current is constant, right? So that means this is VC, this is output current, where you have to make the input current constant. Now just remember, what does it mean input current constant? That means you have to fix this voltage, right? This is a VBE voltage. You have to fix this voltage first, and then you are changing this voltage. That means already the voltage VCE already changing, and depending on the changing, you are just noting the output current. What I'm saying, you just remember one thing. I have to first fix the VBE, VBB. VBB means if we fix the VBE, that means VBE is also fixed because our input current is constant. And now you are changing the output voltage, and you see that how the output current will vary. That is my target. আমরা ইনপুট ভোল্টেজকে ফিক্সড করে দেবো প্রথমে, and then I am changing the output voltage, and we will see how the output current will vary. So input voltage fixed, what does it mean? That means you have to maintain, say, I'm saying that input voltage is fixed as 5 volt. First, you have to fix that. You are not changing that. That means for 5 volt, I am seeing if we change the VC from 0 to some value, how the IC will change. Then you are again fixed this into 6 volt, and you are also changing the VC from 0 to some voltage, and you will see how the IC will vary. Again you have to change the input voltage will be fixed to 6 volt, say, and then you are changing the output voltage from 0 to some value, and you will see how it will change, how the changes will take place depending on VC. Okay, so just remember, when you have to fix as 5 volt, say, then what will happen? Say 5 electron per second, say, I'm just give you the approximate thing. Say 5 electron per second will be attracted by the base because you are fixing 5 volt. That means what will happen? In per second, this base will attract 5 electron per second, right? That is become fixed. And now you are changing this collector current, collector voltage from 0 degree, from 0 volt to some voltage. Then what will happen? That means 5 electron per second that will be attracted. Now you are changing the VCE. Then what will happen? You will get some current. You will get some current, and after certain time it will fixed. Why it will fixed? Because you understood the thing. Because 5 electron per second that will be attracted by the base junction, you are changing the VC value from 0 to say 5 volt. When it is 1 volt, already 5 electron per second will be attracted by the collector. Then becomes the current will be constant. কারণ আর কোন ইলেকট্রন নেই। কি বললাম? ভিবি যখন আমি ফিক্সড করেছি, ধরো 5 ভোল্টেজ, আমি ধরে নিচ্ছি 5খানা ইলেকট্রন পার সেকেন্ডে বেস জাংশনটা অ্যাট্রাক্ট করছে। এবার আমি কালেক্টর ভোল্টেজটাকে আমি 0 থেকে শুরু করছি, ভ্যারি করছি 5 ভোল্ট পর্যন্ত। যেই 1 ভোল্টেজ হলো, ও দেখা গেল 5টা ইলেকট্রনকে অ্যাট্রাক্ট করছে পার সেকেন্ডে। তার মানে কি, কারেন্টটা একটু বেড়ে that will become a constant. And since it is connected in a reverse bias, right? So that means after certain time, if we increase the reverse voltage, it will go to the breakdown region. That means current should be infinity. So that's why the current it looks like. So say this is for when IB is say 5 microampere. That means I am just taking an assumption 5 electrons means 5 microampere. The current will be the base current. Now what will happen? You are increase it to 6 volt. 6 volt means you say increase in 10 volt. Then what will happen? 1 2 3 4. If for 5 volt 5 electron will be attracted by the base junctions, when you increase the base voltage, that means now 10 electron per second will be attracted by the base junctions. Then what will happen? You are again changing the output voltage from 0 to 5 volt. Then you will get some more current, but after certain time, when it reaches certain volt, 5 10 electron per second, that should be attracted by the, you know, collector junctions. So it will become constant, and since we already increase the voltage, so it will reach to the breakdown region after some time. That should be the parallel curve. So say the second curve, when IB equals to 10 microampere, so the same thing will happening like that. That means when you are increasing the base voltage, you will get some more amount of electron there, and when you are changing the collector voltage, the collector will attract each and every electron after certain time, so we will get the constant current. And when it reaches the breakdown region, if it reaches the breakdown region, the current is infinity, so that should be symbolized like that. So say this is, so when you increase like that, so the output curve should be like that, right? Output curve should be like that. And say this is for IB when 20 microampere, here the IB is say 30 microampere, it should be like that. Now one more thing that you need to notice, that what will happen when I am not giving any voltage. That means uh, I am not giving any voltage to the base junctions, right? I am not giving any voltage to the base junction. So when I am not giving any voltage to the base junctions and I am increasing the collector voltage, so there should be slightly some electron from the emitter junctions that would be attracted by the collector, but the current that we will get, that is a very minimum. That means current is not there, it's like that, but that's a very few value that you will get, right? Very few value. So you just remember that that there is a region where you will get zero current, right? There is a region where you will get zero current when I am not giving any voltage in the base junctions, though there are some electrons in the emitter region, that electron will be attracted by the collector junctions, so that's why you will get a little bit electrons, right? So a little bit current, and this is near about zero. So you can say that when IB is equals to 0, we will get a very little bit current, that is near about 0 axis, and this is say near about 0 axis, and this is for IB equals to 0 microampere. So this is near about, you can say, within 1 volt, and say the breakdown occur is near about 40 volt. This is the approximate figure. So that is the explanations. If you think about the explanations, the output curve and the input curve should be very like that. And that's why we will get that amount, that type of curve. Actually, আমরা এই জন্য পাই, right? So I think at least you should understood the basic thing. So এটা হয়তো expected বুঝতে পেরেছো কিছুটা হলেও. So just simple আমরা একটা, if we do the problem, concluding problem, say a a transistor, a circuit is given, say this is a 470 kilo ohm, and say this is the transistors where beta DC is equals to 100, This is a resistance. This is a 6.3.6 kilo ohm, and this is nothing but, you can say, this is a 15 volt, and this is the corresponding circuit, and you have to find collector emitter voltage. You have to find collector emitter voltage. জাস্ট ডু ইট, একটুখানি ট্রাই করো, দেন আমি এটা বলছি। So in that particular case, what will happen? The thing is that particular voltage is VBE. You have to find that voltage that is VCE, right? This current is IC, this current is IB, this current is IE. You know that. So in that particular case, it may be possible that for ideal case VB is taken as 0. If it is not ideal, what I am saying, you can take zero point 0.7 volt. But for ideal case, you can take VB is equals to 0 volt, right? So what we know, output, you have to find the VCE, you know VCC minus IC into RC. So what you have to find, you know about the VCC because that is 15 volt. You know IRC because that is 3.6 kilo ohm. What you have to find, IC. So what we know, this is IB. IB is nothing but, you know, VBB minus VBE divided by RB, and here VB is 15 volt, VE is zero point 0.7 volt, and what is RB? RB is nothing but 470 kilo ohm. That means this is 31.9 microampere, right? And then this is IB. Then this is a very simple thing. You have to find the IC. IC is nothing but, you can say, beta into IB. Beta is given 100, IB is 31.9 microampere, so it will give you 3.19 milliampere. And the thing is that then you just put it, Vc equals to Vcc is equals to 15 volt, this is 3.19 milliampere multiplied by the Rc, the value of Rc, that is 3.6 kilo ohm. So 3.6 kilo ohm, that will give you 3.52 volt. So this is nothing but VCE. That is a simple thing. So if you understood the concept, I think you can do the problem. We will see some problems in the next class, but just please go through the whole thing, because that is one of the important thing that you need to understood. If you understood the concept, you can solve all the problems, because there are this type of problem, and the concept base, this is a concept base. So I think at least you should understood the basic thing যেটা তোমাদের বলা হলো। সো যদি কিছু কোশ্চেন্স থাকে, ইউ ক্যান